Hello class, and welcome to tonight's discussion on the OSI model. We are just about to finish week 6 and headed into week 7. For week 6 we read chapter 6 in the Dean textbook, Network Hardware, Switching, and Routing. So I wanted to take some time tonight to review the OSI model. I received a number of questions from students about hardware differences that I think might be best answered or explained by referring to the 7-layer OSI model. Before we get started, however, a couple of reminders. First, the midterm is rapidly approaching. The best way to prepare for the midterm is to take all of the chapter quizzes. Now, most of you are doing this, and most of you are taking advantage of the fact that you can take each quiz twice, and only your highest grade will be recorded. If you are not taking advantage of that policy, please do so. If you have not taken a quiz, if you've missed a quiz, contact me immediately. I will allow you to make up missed quizzes as long as they're taken before the midterm. You cannot make up any quizzes that you have missed prior to the midterm. This is important for two reasons. First, the quizzes on their own make up a large portion of your overall grade. Also, they are the best way to prepare for the final and the midterm. If you are not used to answering the questions as they are posed in the quizzes, you will have a much more difficult time with the midterm and the final, and I might go so far as to say that you would not pass the midterm or the final if you don't perform well on the quizzes. They're that important. So if you have any questions on that, please let me know. Also, the discussion forum. Most of you are participating well by adding things to the discussion forum. I post questions every week, and I expect each student to respond to my questions. Failure to do so is like failing to come to class. It doesn't matter that you might be doing the quizzes or that you might be doing any of the other exercises that are required of this course. If you are not contributing to the discussion forum, you're not counted for the week that the question was posted. If you have any questions about that or how it might have impacted your grade at this point, then please contact me immediately. So, back to the OSI model. I'd like to discuss the OSI model tonight, and again, I hope this is a review, but I want to shed a slightly different light on it than perhaps what's been shown in the Dean textbook. So, let's start by listing the 7 layers of the OSI model. The top layer of the OSI model is the application layer. This is the part of this is the software that you interact with. So a good example here would be an email client. The 6th layer is the presentation layer. Fifth layer is session. 4th layer is transport. Layer 3 is network. Layer 2 is data link. And layer 1 is physical. So here we have the 7 layers of the OSI model. It's important to commit this to memory, not just for this course, but for future networking or IT courses. Also, if you plan to take a certification exam, like the Network Plus exam, then, again, you'll want to have this committed to memory. But there are other reasons to commit it to memory as well, like what I'm about to show you. I'm going to draw a line through the OSI model. Now then, this line marks the transformation from hardware to software. So, what do I mean by that? Below this line, everything is hardware-based. Above this line, everything is software-based. So, looking at the network, data link, and physical layers, I can go and touch a physical component, a data link component, or a network component. Examples of each. At the network layer, a common device is I'll give you a moment to think about it. Common device is a router. At the data link layer, a common device is give you a minute to think about that one too. Hopefully you said switch. And then the bottom layer of the OSI model, physical. An example of a device you might find at the physical layer is, hopefully you said something like NIC, network interface card, or hub. So, for this course, and for a lot of your troubleshooting career, if any of you move on to help desk positions, you will spend a lot of your life working with just these three layers. These are all the physical things that can go wrong with your enterprise. So this includes things like bad NIC cards, bad cables, broken cables, electromagnetic interference, all sorts of network errors that are captured in these first three layers. Now in a moment I'm going to share with you a 4-layer model that for those of you that are interested in going forward and perhaps going after a Cisco certification, Cisco prefers the 4-layer model. So I'll show that to you in just a moment. But the granddaddy of all of these theoretical models, in networking at least, is the OSI model. So just a couple of words about each one of these devices. A router. A router is important in networking because it allows inter-networks to communicate. You can connect dissimilar media and dissimilar networks by using a router. So dissimilar media can be Ethernet to fiber. A few years ago, it might have been something like ArcNet or some sort of cable-based media to Ethernet. But no matter what the difference is, the router can compensate for differences of media. Also, differences in logical media. What I mean by that, if you have a different address classes, so you could connect a Class A network and a Class C network using a router. Data link. A switch is a very powerful device and is what is used to connect your endpoints or your nodes. So a node is anything that accesses the network. It can be a workstation, it can be a laptop, it can be a wireless device, whatever device you use to access either your intra or the internet would be considered a node. And each node needs to have, whether it's a wireless access point or a physically wired switch, needs to have access to a switch. And then at the bottom of the stack here is the NIC and or hub. Now, a router and a switch are what are considered intelligent devices. You can configure them to do all sorts of things, to filter packets based on protocol, based on MAC addresses, time of day, MTU sizes, lots of different parameters that you can set in your network at the switch level to help shape and restrict your traffic for, again, a variety of reasons. Maybe security, maybe performance, maybe geography, lots of different ways and reasons why to tune a switch in a particular way. So a switch is a very powerful device. By contrast, a hub is a dumb device. And by that we mean that it's a repeater. Anything that goes in one port of a hub goes out all the other ports of the hub. There is no way to filter, shape, change any of the information that's coming into a hub. Whatever electrical signal comes in one port, that same electrical signal goes out all the other ports. And for that reason, hubs are really falling out of favor, certainly in enterprise environments. Hubs in a large environment are simply not sustainable. You cannot expect to have a large Ethernet network, for example, that's using hubs. Why is that? Because Ethernet, if we're going to stick with that example, is what's known as a contention-based network. We've discussed this earlier in the course, and a contention-based network means that all of your nodes, all of your endpoints are more or less competing for network access. Now, this is in direct contrast to something like a token ring network, which was very orderly. You could only transmit if you were a node in a token ring network if you had the token. But that doesn't work that way in an Ethernet network. In an Ethernet network, all of the nodes are trying to transmit pretty much all the time. And it's controlled by something called CSMACD, which hopefully you're familiar with that acronym. But all the nodes are trying to transmit at one time. And a hub will propagate those broadcasts without any sort of filtering. So I'll make up a number. Let's say that you've got 100 devices that are connected to a hub, and they're all trying to communicate at the same time. They can be workstations, printers, again, whatever's connected to your network. If there's no way to filter that traffic, either by use of VLANs or by protocol or ports, etc., it's going to be a very loud environment. You're going to have a lot of collisions on your network based purely on the number of appliances that you have connected to it, and as such, your network is likely to fail and will fail if you get up to any substantial numbers. I would say that if you're going to use a hub, for whatever reason, that you're looking at 10 nodes or less as really the optimum limit. And you think about that, and you'll start to introduce latency errors by way of collisions. So the hub, again, is a dumb appliance. Back when client-server became common, or at least more popular, early 90s, hubs were very common because they were cheap, and frankly, networks hadn't gotten fast enough or big enough for them to be obsolete. But with switch prices coming down precipitously, network speeds increasing, the hub has simply fallen out of favor. So, by way of example, if you have a wireless access point in your home, you're likely connecting to something like a Time Warner or some other internet service provider, and you've got a modem that's likely connected to a switch that also has the capability to broadcast wireless signals. And that switch is likely a 4-port switch that also has some neat features built into it, like DHCP. Well, again, those are all abilities that the lowly hub is not able to provide. So falling prices, increased capabilities, the continued push of wireless devices and the internet in general into homes, all those things have sort of come together to push the hub out of common use. So switches and routers, by and large, certainly in an enterprise environment, are the types of devices that you, as an internet professional, as an IT professional, going out into the world, joining help desks, etc., and so forth, these are the devices that you're more than likely going to deal with. So, just a couple of notes about switches and routers. A switch, how do you tell what a switch is? Well, there were some pictures in Chapter 6 that showed some small switches, and then they had one picture, I wasn't sure if it was very clear to everybody, they had a very large switch, maybe 4 feet tall. Both of them were rack mountable, but that's another way that you can tell appliances apart. A router isn't going to have very many interfaces. A router will have something on the order of 4 to 6 ports. And the router usually sits at the top of a stack of network devices that are usually a bunch of switches or maybe other routers. But you don't have that many connections going into a router. A switch, by contrast, can be very small, say 4 ports, but the numbers can go on up to hundreds of ports in a single switch chassis. For an enterprise environment, it's not unusual to have a large enterprise switch like was shown in the Dean textbook this week that costs $500,000 or so. You mount what are called blades of switches into the appliance. The blades normally have 48 ports per blade, so it's very modular, it's easy to upgrade, easy to repair and to troubleshoot. But again, with a switch, you may have 4 switches, which again, if you look at your appliance in your home, if you've got an ISP that's provided you with some sort of wireless access point, you'll probably find that that is a combination wireless access point and switch, and that you're likely to have 4 ports. A hub, just to round this out, is not uncommon for a hub to have anywhere from 4 to say 12 ports. And you can certainly daisy chain or uplink hubs together, but again, hubs are not well suited to an enterprise environment. So your life, again, I want to stress, as an IT professional and as a network analyst or help desk personnel, a lot of the problems that you will encounter will be focused in these layers. So my advice to you is that when you get that first troubleshooting job or help desk job, network analyst, etc., don't hunt zebras. And by that I mean don't think of exotic problems when somebody contacts the help desk and says, hey, I can't do X. I can't connect to the internet. I can't print. Start with the basics. You will be amazed at just how many problems are caused by something that went wrong at the physical level. A bad network card, a broken cable, a severed cable, a broken clip on an RJ45 network plug. Lots of things can happen at this level because, again, these are exposed assets. And this is especially true in small and medium-sized companies that may not have dedicated professional IT people, and they might not have the infrastructure in place that a large company would. So they might not have a dedicated data center, for example, or the proper rack, or lots of other corners may be caught all in the name of saving money. So again, focus on these 3 areas, these 3 layers, as you're looking to troubleshoot a network problem. So this is the 7-layer OSI model. So as promised, I'm going to change gears here for a minute. I want to share with you a 4-layer model that you might find to be a little more intuitive. Now, the 4-layer model doesn't leave anything out, but what it does is it combines layers. So the 4-layer model, again, this is the OSI model. And the 4-layer model combines functional areas. So in the 4-layer model, layers 5, 6, and 7 collectively become known as the application layer. Layer 4 of the OSI model still is known as transport. In the 4-layer model, the network model becomes the inter-network. And then layers 1 and 2 are combined to form what's called the network interface. So, application, transport, inter-network, network interface. So, just 4 layers to deal with, and it makes a lot of sense this way, and I'll tell you why. First of all, we'll start with the application layer. The application layer, if you're looking at this as a developer, your email application that we mentioned previously is an example of an application. The session, the presentation, the application are all bundled together. You're not going to open your workstation or your server and be able to put your finger on session or presentation. It's all part of how the program works in the first place. So if you're a programmer, you might think of this way, or a software developer, you might think of these as distinct sections. But the OSI model, and students sometimes have problems with this, is a logical model. It's meant to be a framework. And what that means is it doesn't always have a one-to-one correlation with something tangible or physical. That's, again, why the bottom 3 layers are nice, because with the bottom 3 layers, at least, we can touch something. We can point to tangible hardware assets at each one of these first 3 layers. So, in the 4-layer model, the 5, 7, 6, and 5 are combined to collectively form the application layer. Transport stays transport. Network becomes internetwork, still retains the same function. And then the data link and the physical become the network interface layer, which again makes sense. So the data link layer, as you recall, has two sublayers, the LLC and the MAC. And since we were talking about network interface, hopefully the first thing that comes to mind for you is something like a port. So a NIC card, for example, provides a port to be able to plug into your network. It's the network interface. And your NIC card must have a MAC address. So it makes sense that logically you would combine these two areas anytime you're having a discussion about a NIC card, because it is in fact your network interface. So these groupings sometimes make more sense to students because they're a little less granular than the 7-layer OSI model. The OSI model has been with us for a long time. Again, it's meant to be a conceptual framework and doesn't offer a one-to-one correlation to hardware or other tangible devices. So, one more thing I want to share with you, and then I will let you go about your business. I'm going to erase the 4-layer model. The MAC address. The MAC address has the following format. It has 6 pairs of numbers. The first half of the numbers, the first 3 pairs, that refers to the manufacturer. And then this is the device. So if you are in a troubleshooting environment, you may need to look up the MAC address, which again is tied to the data link layer, to determine who manufactured your card. Okay, this would prevent you or save you from opening the case, for example. But you might want to know who the manufacturer is so that you can pull down an updated driver. So the 12 or 6 pair, 12 number, 6 pair MAC address will tell you who the manufacturer is, and then it has a unique set of digits here on the end that should be like the device's fingerprint or social security number. There's only supposed to ever be one MAC address per piece of hardware in the world. It's all supposed to be unique. Now, in practice, we know that sometimes duplication does happen. But as long as those devices are not on the same network segment, it won't cause a problem. So, anyway, this MAC address has this format. It's in hex format. And the way you find it on your workstation would be to open a command prompt. For those of you that are using Windows 7, you can go to Start, and in the Run box, type CMD. CMD will bring up a black window, sometimes referred to as a DOS window. And in that DOS window, you can type this command, ipconfig /all. And this will show you all of your network interfaces and the corresponding, and a lot of other information, but it'll show you your network interfaces and your MAC addresses. So again, this could be valuable information when you are troubleshooting. So ipconfig /all. If you're not familiar with that command, you should be. So that concludes tonight's discussion on the OSI model. Hopefully that has dispelled some of the mystery or some of the concerns that might have been introduced with the Chapter 6 in the Dean textbook this week. Again, I will remind you that as you are troubleshooting network problems and trying to understand the protocols as they work on an internetwork, focusing your attention on the first 3 layers of the OSI model would be a very good strategy. That's all I have for you this evening. Again, I'll ask you to please contact me about any quizzes that you have outstanding. And if you have any questions about how your behavior or participation on the discussion forum has impacted your grade, please contact me immediately. Have a good night.